There we go. All right. So good morning, everybody. Today is Wednesday, November 8th, and we continue our work with Excel. We had a really good lab experience face-to-face on Monday as we were working through chapter 3 and chapter 4. Unfortunately, I did not record that lecture, and also I did not address the students in Zoom properly. So the first thing I want to let you know is I did post the spreadsheet we worked on to our Moodle page, but if you have further questions, please don't hesitate to reach out to me either through text or email or to set a Calendly appointment, and I will get you squared away. So that was an oversight on my part, and I would like to correct it if you are not able to access the material that way. So this week we are right here working through the ideas of graphing, which is the textbook chapter 5. Although a lot of people are still working back on chapters 3 and 4, which was due last Friday. So I encourage you to get that work done as soon as possible, then to start working through the graphing exercises. As far as if we take a look, for example, let's just go through this and I'll talk a little bit about graphing from this spreadsheet. Just a second. Let me see if I can get this to open up on my screen properly. Right, not going to get that. So let me pull this up. Where did you go? Technology is having a mind of its own today. So we're going to see what we can come up with here. Yeah, it didn't even come up. All right. So if we open our Excel spreadsheets, let's see if I can pull this up. Okay, great. So I'm going to share the screen. And Derek, do you have the screen do you have an Excel spreadsheet on your screen?
Yes.
Okay, great. So this is how we address problem 3.3 in the textbook. And it's about a series that approximates the value of a cosine using a particular sort of a series. Now, there are a couple of things I wanted to point out is that, first of all, Excel has a cosine function. So this is just looking at approximating that cosine function. But the cosine, like it says here, is just if you say the cosine of whatever is in L1, which here is 5.15, this will return a more or less exact value. Like we had talked about on Monday, the value of a cosine is never really exact unless it hits those marks of 0, 1, or 0.5. Most cosines, and they're sinusoidal functions, most of them are irrational functions. So there is some potential for rounding errors or even having a slightly different value based upon whatever it is that whatever parameters you're using to calculate that function. The other thing I want to point out here is that when you input this number of 5.15 and you ask for the cosine, this is in radians, okay? And a way to check that is, if you remember, if you're in degrees, the cosine of 90 degrees is going to be 1 or 0, excuse me. And if you see here, we don't return a 1 for that value or a 0. So that means that we know we are not working with degrees. So how do you convert from radians to degrees? Those of you who have had trigonometry will know how to do that. But basically, the answer is that there are 2 times pi radians in a circle, and that is the same amount as 180 degrees. Okay, so your conversion factor pi, if you remember, it's also an irrational number. It's approximately 3.14. So, and this is the function in Excel, equals pi with two parentheses. It will turn that number into pi. So 3.141593, but however, it is an irrational number and it goes on forever. So if I were to expand that cell and format that cell with more decimal places, you'll see that it will just go on and on. And no matter how many decimal places I put here, it won't do it. It's too much. All right, so let's say 12. You'll see that it keeps going on. It will never repeat and it will never stop. So, I mean, it will never repeat a pattern. Of course, it will repeat digits because there's only 9 digits, but we'll never really get to an actual exact answer for pi. But what that means is that if there are 2 times pi radians in 180 degrees, that means that if we have radians and we multiply that by 180 and then divide that number by 2 times pi, or approximately 3.14 times 2, or 6.28, that would be the conversion factor. So if I take 5.15, which is the quantity in L1, and I know that that's in radians, and I want to convert that into degrees, I would multiply that number by 180, and then I would divide that number by 2 pi. So I could put in parentheses 2 times pi, parentheses, and I'd get 147 degrees. Okay, now to check that out, to make sure that it's working properly, let's say, what if I had 2 times pi radians here? So 2 times pi, this number should come up to be 180. So that's how I know that my numbers work. But if I do that, then what do I see about the cosine of that number? Well, it's 1, which was my whole goal in the first place, to make sure that I've got that value. What if I put in 90? That would actually be pi radians. I don't have that recalculated. If not, we need to have that's what I'm looking for, the cosine of L1, and I want to take M1 multiplied by that factor. So hang on just a second. Equals M1 times that factor. So then it would be, if I take my radians, okay, this is degrees, that's why I'm doing that wrong. So let me just get out of that. If I'm going from the other way around, if I start with degrees and I want to change it into radians, I would do the opposite conversion factor. So in other words, I would take that number times 2 pi, 6.28, round it off, and divide it by 180. And that's how it convert to degrees. So those are the 2 conversion factors that you can use to go back and forth. But just a quick, easy check to see if a program or your calculator is in radians or degrees, is to just plug in a value that you know. For example, 90 degrees, you know what the cosine of that is going to look like, or 180 degrees, you know what the cosine of that is going to look like, and see if you get that value returned. And if you do, then you know you're in the right set of units. Otherwise, you want to try to convert from either degrees to radians, or radians to degrees, whatever you're looking for. All right, so continuing with that thought, the formula here beginning in J5 is an approximation of a series that calculates the approximate value of a cosine. Now, it's pretty interesting because x is the number of radians in the angle that you're computing, and you take it raised to the 246. So in other words, ascending even number power, and divide by the factorial of that power. So basically, that's what this spreadsheet sets up. We take this value of n, and then we take that value and we raise it to the factorial. But I did these all by that function of fact, which is just factorial. So the factorial of 4 is 4 times 3 times 2 times 1, and so forth. But then if you look at it, the series alternates signs. So first we start with 1, but then the next term has a negative sign. So I did alternating signs here by multiplying the cell above by -1, and that changes the sign every single time. And then I add everything together. And so if you look at the adding everything together, you'll notice that I anchor the first cell. So in other words, I always want to start at F3, but here I want to go to F4, here I want to go to F5, and so forth. So it's just every time I add above, I add all the terms together. Now, what you see here is what's called convergence. Here on line 14, which is the 11th or 12th term, depending on if you consider the one is a term. But anyway, we start to converge on a number, which is 0.42377. And if you remember when I had my numbers in here, let's see, this is going to be the cosine of L1. So here I want to put in 5.15, or what am I using for my number? 5.15. That would converge at 4.42377. Okay, so in other words, you see that the actual value that calculates from a cosine function converges at 0.42377, and it does that in about 11 terms. Now, the thing about series is there is a formula, and it's in the later part of that problem in your textbook that gives you not an iterative solution like this, but just a formula that you can put in a cell that will execute that infinite series. However, I did it this way to kind of show you some things. First of all, how to work with Excel to get those terms, how to add things up, how to compare an exact value to an approximated value, and then just to do the problem solving involved in how do you structure in a series as a convergence, or as how do you structure a series as an Excel spreadsheet. So all of those things involve a lot of problem solving. The other piece that I just wanted to state or to let you know is this series converges, meaning that within some number of terms, the numbers all become quite similar, almost identical to each other, depending on how many decimal places you display. Not all series converge. A lot of series diverge. And if that happens, these techniques will not work. You need to use other analysis techniques in order to make divergent series turn into something. And it's a much more complicated problem. So at this stage of the game, any series that you are given to solve in a class like ES 1060 or Computer Science 1010 will converge. But just so that you recognize that's an expectation of this class, but it's not expectation of series in general. All right. So anybody have any questions about that particular series? Okay, or the problems. So what we're going to do then is work through this material. And once again, if we go back to our Moodle page, you can see, let me get this up here, share my screen. Here we go. That by this Friday, you should have the graphing exercises done for chapter 5. So I'll check the homework again on Friday and see what's turned in and get caught up on my grading. But we're really getting close to Thanksgiving. So it's at Thanksgiving, I take a moment and I sort of have I sort of go through and regrade everything to make sure everybody knows how they are coming into finals, and if there are any problems, it'll still give you a couple weeks to get caught up. But next week on Monday, Tuesday, and Wednesday, I will be working remotely, so we will only meet by Zoom on those days, but I will hold class Monday morning, lab Monday afternoon, and class Wednesday morning. But the basic mission will be to be finishing up chapter 5, and then we're going to start working in chapter 6 next week. So if you have any questions, like I said, I'm not going to be on campus, but I will be available through Calendly, through text, through emails. So I'm not going anywhere exciting. I'm just going to Cheyenne. So I will be available just like I am if I'm on campus. So do you guys have any questions for me or any comments, anything about the work so far? All right. Well, I will go ahead and stop recording, and that's it for today. So please keep working ahead and do not hesitate to get a hold of me if you have questions or if I can help you with your work in any way. Have a great day today.